4. 6h squared minus 5h minus 6. Now what? What don't you like there? You don't like that 6. When it was just an h, we needed to multiply to 6 and add to 5, right? But it's not just an h, it's 6 times bigger than an h. So we need to multiply to something 6 times bigger than 6. So we're going to multiply to negative 36, and we're going to add to negative 5. Is it 1 and 36? No. 2 and 18? No. 3 and 12? No. 4 and 9? Yes. Which one is it? Positive 4 minus 9 or positive 9 minus 4? Positive 4 minus 9. So it's 4, because we can't forget about 4. H plus 4, but it's not really plus 4. What is it really? 4 over 6. And it's h minus 9, but it's not really 9. It's 9 over 6. And then what do I do with those yucky fractions? Simplify. 4 over 6 becomes 2/3. And 9 over 6 becomes 3/2. What do I do with those denominators? Move them to the front. 2h minus 3. And then I always check. Is 3 times 2 6? Yes. Is 2 times 3 6? Yes. Then if I put that 4 back in, do I get that? Yes. Now, the question becomes, can I just write answers, or do you need to see them worked through still? Because we're at the end of the unit. If you are at a point now where you still need to see some of these worked through, I don't mind doing it, because we're nearing the end of a unit. But the warning I am giving you is if you're writing all these down and it is making no sense to you, when should I see you? Not X block. Lunch. When? Today would be a good day, considering this is the very last new thing in this unit, right? Okay, so this one is 12, 13, so it's 12 and 1, so it's 12n minus 1, I lie, 12n plus 1, and n plus 6. No, that's not right. Idiot. I can't even do that one in my head today. So it's n plus, it's got to be 12, so it's n plus 12 over 2, n plus 1 over 2, so it's n plus 6, and 2n plus 1. There we go. Now my brain's working. Now, question becomes, does order matter? Order of binomials, does it matter? If you wrote 2n plus 1 and n plus 6, does it matter? No. Would it matter if the signs were reversed? Sometimes, right? Got to keep your eye on that. This guy is 12, so this guy is t plus, it's got to be 12, 6 and 2, t plus 6 over 3, t plus 2 over 3, which is t plus 2, and 3t plus 2. There's that one. Any questions? Excellent. That's m plus 14 over 2, m plus 1 over 2 to get m plus 7, and 2m plus 1. You are either checking your work or you are writing this down. What changes in 9? What looks different in 9, I should say? It's a squared in the middle, and it's a fourth power out here. Well, everything we've done before ends up as 2n and n times n gets 2n squared, right? So what's going to be different here? I need a fourth, so it must be what? Squared and squared. That's the only thing that changes, right? You don't look at something new and say, I don't know how to do it. you try what you already know, right? And what you already know says you should do 9 times 4 to get 36, and you should recognize that 6 and 6 makes 12, right? So it's t plus 6 and t plus 6, which I reduce to 3 halves, which I reduce to 3 halves, 2t plus 3. I lie. 2/3. It's not 2/3. 2/3. 3t plus 2. 3t plus 2. Then I check. 3t times 3t is 9t squared. Oh, crap, I need 9t to the 4th, so you remember to add in your 4th. Now, can I leave it that way? Yes, but I also could recognize that it's 3t squared plus 2 squared. Now, you should also notice something there and there. What did you notice? In my final answer as well. Not divided by 2. They're square roots, right? Square root of 9t to the 4th, 3t squared. Square root of 4, 2. If they're perfect squares on the end, that's another thing that you could maybe see, right? I don't like to show you that because then kids start looking at something like this and see a perfect square there and start trying to do weird shortcuts instead of math, right? That guy is 8, so it's y, but it's -7 and -8, so it's y plus 1 over 2, y minus 8 over 2, which is 2y plus 1, and y minus 4. That one is 18, 9 and 2, n plus 9, n plus 2, simplify, 2n plus 3, 3n plus 1. 4 and 10, 40, -40, but 3. So it's m plus 8 over 4, m minus 5 over 4, 2, m plus 2, 4m minus 5. Look at this one. What do you see? Because I know a lot of people haven't done this. So now that we've talked about it, what do you see there that might help you out? Looks a lot like 9, doesn't it? Is that a square root? Is that a square root? So check it. Could it be 2a minus 1 times 2a minus 1? 2a times 2a is 4. -2a is -4a. 1 times 1 is 1. Done. This one, you already know how to do those. Y plus 7, y minus 7. Just thrown in there to keep you reminded. What's different about 15? Can I use what I know in 14 to do 15? Yes. Right? Because isn't this the exact same as saying putting a y there like I had there? So this would be y plus 9, y minus 9, yeah? But there's no y. What is it really? X minus 7 plus 9, which is what? -7 plus 9, guys. Plus 2. And -7 minus 9. X minus 16. Already showed you how to do that. It's in the recording. It's the exact same thing. A and B, square root of both. Showed you how to do 18. It's in the recording. A and A, because they're the exact same thing. That's X plus 6. X plus 2. There we go. And then this one is probably the second hardest factor in question I can give you. The only way that would make this any harder was if I put a coefficient out in front, which I didn't. So that, because those are the same, what are you allowed to do? Make it any other variable. Does it have to be A? No, you can make it anything you want, right? Fish squared minus 4 fish minus 45, right? 45, it's got to be what to get negative 4? It's got to be 9 minus 5, right? Other way around. Negative 9 plus 5. So it's fish plus 5, fish minus 9, but it's not really a fish, it's 4x plus 3. 4x plus 3 plus 5 is 4x plus 8. And 4x plus 3 minus 9 is 4x minus 6. Now, how many of you want to stop there? The majority of you should be putting your hand up right now, because you've done a crap ton of factoring, haven't you? But are you done? Why not? Because what do you see there and there? 4 and 8 simplify, don't they? What goes into 4 and 8? 4. So what's coming out of here? 4. And what's staying in there? X plus 2, right? What's coming out of here? 2. What's staying in there? 2x minus 3, yeah? What's 4 times 2? 8. X plus 2, 2x minus 3. And that would be the perfect answer. Okay? If you get to here, happy face. If you get to the bottom one, big happy face with the tongue sticking out, cross eyes, upside down because I'm halfway through a cartwheel. Okay? Just depends on where you want to get to. Everybody good? Yep. Yeah, all right. So, we're done with this unit. If you can handle it, you should be able to. So, let's do 139 right now. It's only 15 questions. Then you'll see page 140 is blank. That's because I want to put some kind of crazy ones there and see if you can really do them. Okay? Everybody good? And now, today's only Tuesday. Is it going to mess you guys up too much to wait until Thursday for this test when I am not here? No, it'll be okay? Because what we're doing, the next unit, the first thing in it, has almost no math. It's thinking. Okay, like there's no math to do with it. It's reading a graph. There's some new words, but there's no math. Everybody cool? That'll be fine? Okay, go with 139. I'm going to make up some questions for the blank on 140. And then as soon as I've made up a couple, I'll start walking around. Everybody cool? Okay, go. Yep. Okay. Ow. Good? Good? Yeah. Really? And for true? Then what? Which part? Where? You've done four different kinds of factors. Which one can't you do? Don't give me the clue that you can't learn, because I know you in GCS. Yeah, you can do that. Okay, so you're not supposed to go. Which one? Okay. Which one of that stuff? And you do this one. Where we just go up to the end, top it up in front. Where I got to slide a 20 and add a 12. And you do those. Okay, so do that. No number out in front, so I'm going to multiply to 1. Multiply to that one, add all that. Well, not necessarily. You multiply to that one, we get nothing. So you got to multiply 16 and add 8. This. Oh, it's the right time. Multiply to 16 and add to what? 8. So it's 1 to 16. Well, 1 plus 16, which multiplies to 16. No, 2 and 8. Yes. 4 and 4. So it must be 4 and 4, right? And since these are both positives, x plus 4, x plus 4. Right, and then you bracket. Okay, so now, let's do that one. What do I have to multiply? 18. What do I have to add? 11. Closer to the 11. Why? Help him out. Or not? Got to multiply 18. It's perfect. He said he wants to add to 11. Negative 11. Good man. Oh. Okay, so now, is it 1 and 18? 1 and 18. Never get to 11. Yeah. 2 and 9. Yeah. Yes. How will you get 2 and 9? Negative 4 is plus 2 minus 9. Negative 2, negative 9. It's a 9. Can it both be negative? Yeah. Yes. Okay, so it's x minus 9 and x minus 2. Then we check. Is 9 times negative 9 times negative 2 positive 8? Yeah. Yes. Is negative 9 minus 2 negative 11? Yeah. Is x times x squared? Yeah. So you're done. Oh. Can you do these? Yeah. Great. Do 11. Because it looks slightly different. Look closer at that 10. There you go. And you're going to add it to what? So, is it 1 and 10? No. Is it 2 and 5? No. 2 and 5? Oh, no. Negative 2. Right. Negative 2 plus 5. So it's x minus 2. And check. check, you can have this, right? Here's what I mean. Is negative 2 times negative 5 negative 10? Is negative 2 plus 5 positive 3? Yeah. Is x minus x equal 4? No. No, so it must be x squared. Okay, can you do those? Yeah. Great. Moving on. This one. Notice, when they are exactly the same with a minus in between, what happens? The term disappears, right? Oh, yeah. So as soon as you see a perfect square minus a perfect square, square root of the first one, square root of the second, add. And you write the same thing with a minus sign. That's it. Okay. So let's do a couple of those ones. You haven't done any. Is that a perfect square? Sure, it's set right there. Square. Is that a perfect square? 49 times square. 49 times square root. Oh, it is. Yes. What is it? 7. So we take square root of the first one, x, plus square root of the second one is 7. And you just write it again. That's it. That's done. Hey, you guys stress yourselves out. You think math is hard. It's not. Is that a perfect square? Yes. 9 have a square root. What is it? 3. Does x squared have a square root? Yes. What is x? 3x. Plus. It's 25 have a square root. Yes. What is it? 5. Does y squared have a square root? Yes. What is it? Y. And then let's do it again. X minus 5. Y. Does 2 have a square root? Yes. No. Does 50? No. Then you got to think, oh, but wait a minute. 2 and 50 are GCF. What's the GCF of 2 and 50? 2 only has 2 factors. Yeah. One, it has to be 2, right? Yeah. Okay, take out the 2. What's minus? X squared minus 25. Out of square. X. Done. Fourth this time. Square root. X squared. Right. X squared. Square root of 1. Then what do we do? Write it again. Minus. Now, close. Is that a perfect square? Yes. Is that a perfect square? Yeah. Once we gotta keep going, don't we? You forget about this guy? No. X squared plus 1. And then this guy, what's square root of x squared? X square root of 1. 1. Write it again. That's all the squares. Now this is taking you back a few pages. Make sure you can still do it. There's 3 of them. So I gotta multiply what back to what? 60 times 7. So I just start working it in my head. Is it 1 and 6? 30. Yeah. 30, but they won't make 17. Will they? Is it 3 and 20? Yes. 3 and 20. If I negative 3 plus 20. Negative 20 plus 3. But if I multiply negative 20, I positive 3. So I get positive 16. No, so they can't be 20 and 30. We're going to keep going. Is it 4 and 15? No. Is it 5 and 12? Yes. Yes. Negative 5 and negative 12 will make negative 17. Negative will make positive. X minus 12. X minus 5. Right? Now we're back to the squares again. Is that a perfect square? Yes. What is it? Is that a perfect square? You write that. You fire to write this. It's upside down. Okay, number 1. All those are yes. And pretty hard, huh? Okay, look at number 7. Number 7 looked like 1. Only had a 3. What did we do when we had a 3 in front? When it was a perfect square, we just square root it. 3 doesn't have a perfect square, does it? So what do we do when we have to get rid of it? We divide it by that number, right? So we're going to try that here. What's 3 divided by 3? So we write 3 out front, bracket, and then now the next square, right? And now, 48 divided by 3. I can't do that. I just fire, so what do we do? 16. X squared minus 16. Now, is that a square root? Yes. Is that? Yes. So finish. And do I leave the 3? I'll leave the 3 as part of the equation. Okay, what's different than 8? They both got 8, so what should we do? Yeah, we gotta get rid of the 8, right? How do I get the 8 out? How do I get 3 out? How do I get 2 out? Right, so what do we do there? Right, divide by 8. 8 squared, 8 cubed divided by 8. How many 8's are on top? 3. How many 8's are on the bottom? How many 8's do? Divide, right? So divide this. Oh, 3 up. What do you do? Great. What do you do with the exponents when you divide? Oh, subtract. Great. So A out front, and what's underneath? Yes, A2. A2. Oh, A out, A, and that's the A squared. That's A squared down. There's only 1 A there. We take out 1 A. So that left us 2 A. And over here, that 1 A is gone, so let's see minus what? 4. 16. Now, that, brackets. Right. That A up front. What do I do here? I change Great. And we write again. What sign? Yes. Yeah. That's negative. Now, what would you like about 9? What big number? No, 72 is the 8 is what's bothering you. The 8 is a perfect square. So what do you do? Yes. What do you do? By what? 8. Great. Now rewrite. Where does the 8 go? Up front. Then what's in the brackets? Just A squared right now. Only dealt with the 8. Minus 72. Great. Perfect squares. So it's A. So now you know what you do there, with that. Oh, there you go. And then there you go. All right, so you're good with squares. Yeah. Now we go to this one. Now, here's the example. If that wasn't there, I showed you that. There's 3 of them, there's no number out in front, so you gotta multiply the 24 and add it. Right? Okay. Now in this one, you'll notice there's a 6 out front, right? If there was no 6 there, we would need to multiply the 2 and add the 2, right? Or add the 1, right? Because that's a square. Right? So we multiply the 2 and add the 1. But this has a 6, which means it's 6 times bigger, right? So I don't multiply the 2. I'm going to multiply the 6 times bigger than 2, which is 12. Take the 6 and I multiply by that. But I still got to add the 1. So that's why it was 3 and 4. But I gotta remember, when I have the 3 and the 4, that it was actually multiplied by 6, wasn't it? And I haven't done any division, have I? So when I get the x plus 3 and x minus 4, I have to remember those are really divided by 6. And then we never leave fractions. So 3 divided by 6 is x plus 2. And 4 over 6 is 2/3, right? Just bring that to the front. So we get 3x plus 2. And that's how you do all those. Same thing we did the very first one that had 3 elements, and I gotta remember to multiply by that first big number. Okay? So let's do that one, the first big number, right? Right. Can't get rid of it, because if we can't divide everything out, 7 doesn't divide by 5. So I gotta bring 5 over to here, which means I need to multiply to 1. No 5 there. Now we've got a 5, it's got to be 5 times 2. It's got to be 5 times bigger. Multiply to 10, and I add a 7. Is it 1 and 10? Is it 2 and 5? Yes. Yes. So x plus 2. But it's not really plus 2. Because I multiply by 5. And I need space so I can put my simplifier in there. And then it's x plus 5, right? It's not really 5, multiplied by 5, so I divide by 5, right? What does that simplify to? 5 divided by 5 is what? 1. That doesn't simplify, right? It's the denominator. That's the front. So 5 x plus 2. X plus 1. Then I check. It's 5x times x, 5x squared. Yes, right. It's 2 times 1, 2. So I'm right. Right in front and right in the back. So this one. If there was no 2 there, I need to multiply to 6, right? Or I need to really multiply. 12. Multiply to 12 and add to what? 7. Is it 1 and 12? 2 and 6. Yes. 2 and 6 makes 7. No. 3 and 4. Yes. Yes. X plus 3. But it's not really plus 3 because what did we do? Multiply by 2. So what do I got to do again? Divide by 2. And then x plus 4, but it's not really 4. Divide by 2. Divide by fractions, that's simplified. Nope. 2 goes in front. 2x plus 4. What about that? 2. So that is x plus. So then we check. 2 times x. Is 3 times 2 6. What about that one? What do I gotta multiply? 18. What kind of 18? Negative 18. What do I gotta add to? 17. Is it 1 and 18? No. Wait, yeah. So. Bye. Absolutely right. So that's x plus 18. It's not really 18. Divided by 6. X plus, minus 1. That's not really 1. If I simplify, 2. Divided by 6 is 2. 3. That's simplified. Where it happens to 6. X minus 1. Then I check. X times 6 is x squared. Yes. It's 3 times negative 1, negative 3. Yes. Right? Yes. Done. And that's all the factors. That's every time. Now, you might lose a couple of marks when you get the crazy ones. Like those. Yeah. But look what I did. Since that's the same as that, right? You made them the same letter, and then it looks normal. And you just do it. Until you get to the end, a plus 6. But it's not a, because it's 2x plus 7. So 2x plus 7 plus 6, which is 2x plus 13. Okay?
Thank you.
You listen to all that. Now do it.
Thank you very much.
5 more minutes, and then I want to show you the right answers to what page are we on 38? 139? And then, oh man, I bet I left that thing recorded. Oh, what an idiot. And then there's 6 or 8 questions that are recorded on YouTube. If you want, you can check them tonight and do them, because they're hard. They're really hard. All of them. Everyone needs a trick, I think. Needs a trick. Not a trick, but everyone is more than one step. Good? 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 No, thanks. Thanks for offering. That's one of my favorite ASDF ones where the guy says carrots are good for your eyes and he stabs his eyes. It's not as good as train. What? Okay. Pretend E isn't there. What would you do if E wasn't there? Oh, you're right. What a 40. And add 1. So it's 1 and 40. 22. Okay, so it's A plus 20. Yeah. But it's not really plus 20, it's 38, right? Okay, space for simplifying. Just put your bracket a little further away. And then what's the other one?
I just put N.
Let's simplify those brackets. Two, extra 10 and 4. That's the only thing that's smaller. 2 again, 5 over 2. And then you're done. That's 5 over 2. Excellent. Now we're going to go those non X's and 5
No, the bigger one that you do.
Yeah, okay. And yeah, all right. Now, check. Is 2D times 2D 8D squared. 2 times 4. That's right. It's 5 times 1 is 5. But it's not E squared, is it? So what I need there and there is E squared.
But then this is 4.
See, that's what drives us crazy. You guys, you can see that D and D will make D squared. It's not just D squared. What do you need? Just D and E. If you have been derelict in your math work, and by that I mean you have not been keeping up with the pages I have assigned, if you can do page 139 and the 6 questions I've written on here that are recorded on YouTube, if you can do those 2 things, page 139 and the page that I have up that I wrote, which looks like this, if you need it now, if you can do these 6 questions and you can do page 139, then you're ready for your test if you have not been keeping up. Okay? I'll say this again tomorrow. I'm just going to remind you now. Your test is multiplying polynomials and factoring polynomials. Multiplying starts out with just this. A times B plus C is AB plus AC. You distribute. You also need to know this one. A plus B, A plus C. Double distribute. A squared plus BA plus CA plus B times C. You need to know that. And you need to know triple distribution. One of 2 ways. Either either A plus B cubed, which is A plus B, A plus B, A plus B, and then FOIL, or A plus B, A plus B plus C. Triple that way. That's all the multiplying you need to do. Factoring, you need to be able to GCF. You need to be able to do x squared plus bx plus c, which is multiply to c and add to b. You need to do difference of squares, which is a squared minus b squared, which is just square root a plus square root b, and then you write it again, minus, and you need to be able to do ax squared plus bx plus c, which is you need to multiply to a times c and add to b, and then deal with your fractions. That's everything you need for this test. And you will notice, hopefully, that that very first thing that you learned in grade 9 is actually the only thing you need to know for all the multiplying, isn't it? Because it's just distribution. You learn that in the 9th grade. Most of you learned that in the 8th grade, because when I taught it to you in grade 9, most of you said, oh yeah, I already knew that. At least most of the grade 9s I taught. I only taught 3 of you guys in grade 9. But all 3 of those people said, I already knew that. So all the rest of this is that same thing, yes? GCF, you should have no problem with that. And then this relates to that almost directly. And that is the only thing that's really crazy new. Okay? Okay. Now, some of you are going to want to see some right answers from 139 before you go home to make sure that you're doing it right. Computer's frozen. I got 13 minutes. I'll do a couple of these ones that are kind of a little trickier. For example, I'll do 7. Because 7 looks freaky. Because if you just follow the steps, 7's difficult. Because you're going to go 15 times 10, and you've got factors of 150, right? Who wants to do that? Not me. But of course, what you should have done first was recognized that all of that divides by 5, doesn't it? So what I really have is 3k squared minus k minus 2. Now I've only got a 3 and a 2 to deal with, right? What's 3 times 2? I got to multiply to negative 6 and add to negative 1. What is it? Is it 1 and 6? Is it 3 and 2? It's 3 and 2. K plus 2, but it's not really plus 2. What is it really, Daniel? Over 3, right? And it's K minus 3, but it's not really minus 3.
It's
Divided by 3. And then I simplify the fractions. Does that one simplify? Nope. So it's 5. 3 goes to the front plus 2. Does that one simplify?
Yes.
To what?
1.
So it's K minus 1. That's about the hardest one on this sheet. Because every other one that looks that hard with crazy big numbers, like, oh, say, 12 times 30, I bet you can do a GCF there, because 12 times 30 is a real big number. And there's a couple of other ones. Notice there, 3x's, 2x's, 1x. Is there a GCF? Yep, bet you can do something there. E squared. If there's an E squared there and there's a D squared, my answer better have D's and E's, right? And then here are the extra 6. If you are one of the, one people in the world that say you cannot get on the internet at all, ever, in no way it is possible for you to go on the internet, ever, like you live in a cave with no power and you can't get to the library in this building that you get to every day, you can't get on the internet to get these questions, here they all are. I would recommend writing them down now. I'm going to move it so all 6 are on the screen at once. Ah! Ah! Where'd 3 and 4 go?
I ate.
No, you ate SpaghettiOs.
Oh, yeah, good point.
Did somebody write down 3 and 4?
No.
Of course you didn't. Huh? You got 4? You got 3? Great. What was 3? 4. X minus 4. Minus 25. And 4 was, Rihanna? Minus 24. There. Piece of crap. You can do 139 and 140 even if you've done nothing else through this whole unit. You've got X's on both homework checks and you failed both your quizzes. You can do those 2 pages. You're fine. Okay? Okay. But Mr. Myers, how can factoring make multiplication okay. Well, because at the end of factoring, you should be checking, right? And how do you check factoring? You multiply. Gouda? Great. But of course, you would never grate Gouda, because the only reason to grate cheese is to melt it somewhere. And I don't think melting Gouda would be very good. Although, some places do put Gouda on burgers if you ask for it. So now that makes me want to try it, even though I know I don't like Gouda. It's no Gouda.
I get it.
You have no idea how much this hurts because I have a broken knuckle right now.
Oh.
I think I have a broken knuckle. It feels like it was broken. One time I was doing karate and a guy kicked and I went to block it and I didn't sweep it out far enough and I punched his foot as he was coming up to kick and he broke my knuckle. He went,
That must have hurt.
it hurt like heck. I finished the match, but it still hurt. And this feels like that. So I think I have a broken knuckle.
Did his leg hurt?
Yes.
Oh, poor guy.
Thanks.
I'm kidding. Oh, poor guy, I don't know.
He's a punk kid. 17-year-old kid.
Wait, did you win?
Yeah. That's why he was kicking so hard, because I always beat his ass. Every time. Because I'm old. Huh? No. No.